Okay, let's talk about the paper folding activity that I did in class. So I gave it the class sheet of paper, and they were supposed to fold same amount on each side. So I'm just picking a size, trying to match it all the way around so that all these folds fold up the same amount, which means if I could see the paper here, this should look like a square. And fold each side up equally. So this should look like a square there and here. And then if I open it up like this and do a little work like this, if I've done a good estimate, these should be the same height on the corner here, and make a corner of a box. Move this up to there. I wasn't very good there. I got a little bit different in the heights, but that's the idea. And I can make this box. This matched up. And let's see if this one matches up. No, I messed up somewhere. But I get a box. Can you see the box? And a box has a volume. This is an open top box, but I don't want to heap it up. I want to know what the volume of just filling it full is. Well, you should know that if you have a box, its volume is the area of the base, which is width times length times the height. So to find the volume of my box, I'm going to measure how high I fold it up. And one of the things I want you to learn from this is I want to see if you do know how to measure how much I fold it up. So I got to make sure the mark, which is not the end of the ruler, it's right there, is on the fold. Does that look like it's lined up with the fold? I'm looking at my camera and it says there's the fold, and I think they line up pretty darn close. And it looks like it ends right there. Now, some of you don't know how to read the marks on a ruler. And so that's one of the goals of this, is to be able to understand the ruler. If that is 0 and that's 1 inch, most of you know that's a ½ inch. And if I take half of a half, I get a quarter. But why is this called a quarter? Well, it says I've divided it into 4 pieces. 1, 2, 3, 4. 4 lengths of 1/4 make a inch. 2 lengths of 1/2 make an inch. If I cut a quarter in half, I get this spot. And that spot's called half of a quarter is 1/8. And it takes 1, 2, 3, 4, 5, 6, 7, 8 eighths to make an inch. And if I cut an eighth in half, I get a 16th. So these little marks are 16ths of an inch, and there's 16 of them. 1, 2. Now, notice I don't count marks. I don't go 1, 2, 3. I count spaces. 1, 2, 3, 4, 5th space, 6th space, 7th space, 8th space gets me halfway, and another 8 gets me all the way. 16 sixteenths. So this is a 16th. If I went halfway between those, there'd be 30 seconds. And there would be 32 of them to make an inch. Okay? So I have an inch plus, it ends not on these 8th marks, 8 of them, and ends up on a 16th. So 1 inch and 1, 2, 3, 4, 5, 6, 7/16. So I folded up 1 7/16, and I was supposed to do that on all sides. So the volume is width. Well, the width of my box is going to be from here to there. Now, the width of the paper, which I expect you to know, a regular sheet of paper, is 8.5 inches. But the width here is going to be 8.5 minus how much I folded up on this side and minus how much I folded up on this side. Well, each of those is 1 7/16. So I got to take away 1 7/16 twice from 8, and I'll get the width of the box I made. So I don't need to make more than just one measurement. The length of a sheet of paper, normal paper that I have here, is 11. But I folded up 1 7/16 there, 1 7/16 there. So I have 11 minus two of these 1 7/16. And the height of the box will be 1 7/16. So my volume is going to be 8.5 minus 2 times 1 7/16 times 11 minus 2 times 1 7/16 times 1 7/16. So I'm going to grab my calculator and show you, in case you don't know how, to enter this on a calculator. So on a calculator, let's see, get this in a place where the reflection's not so bad. I got to do parenthesis. Well, I can do 8.5 for 8.5 minus 2 parentheses 1 and plus 7/16, 7 divided by 16. That's how I can do 2 times 1 7/16, close parenthesis. So I got 8.5 minus 2 of those, open parenthesis, 11 minus 2 parentheses 1 plus 7 divided by 16. Close parenthesis for that one, and then the height, 1 plus 7 divided by 16. And I get a volume of, I messed up. There must have been something else. Oh, and I got plus in here. Let's go back and look at what I put in. It should have been 1 plus 7/16, 1 minus 2 of 1 7. Oh, not 1, 11. There's the problem. It should have been 11 minus 2 7/16, and it should have been 8.5 minus 2 times 1 7/16. So I messed up a couple spots there. Right, now I have it in correctly, and I get a volume of 65.698. And this was in inches, this was in inches, and this was in inches. So I'm multiplying, so I've gotten inches cubed, or cubic inches. You can write it either way. That's the volume of my box. Now, what I wanted you to do in class was to try to guess how much to fold up to make it have the most possible volume. So, is this the most? Did I do a good guess? Well, let's find out. Now I'm going to say, instead of 1 7/16, what if I said I folded up X amount? Then my volume would have been 8.5 minus 2 times the amount I folded up, 11 minus 2 times the amount I folded up, and then times the amount I folded up. That's the volume. I'm going to go to the calculator, and I'm going to type that in and graph it. Oh, I want to put 8.5 minus 2x, 11 minus 2x, and x. Width times length times height. Now if I push graph, let's go. It looks something like this. Get it out of the reflection. And it goes up, and then it comes down and goes up. So x's are the amount I'm folding up, and I could have been 0 through, it goes on forever. I could have folded up. No, I don't think I could fold up forever length and width. I'm going to be limited by how wide the paper is or how long it is. So I'm probably stuck in here, and the maximum probably is there. So if I go second, no, I think maybe I should do zoom 6. Some of you may have made the graph like this, and it goes off the screen. I had adjusted this already, so I'm going to go back and readjust it. It goes too high. I have a max of, my was 65. I don't know if it's the most, so I might want to make my window, I'm pushing the window button, and I'll make the Y maximum more like 60, like maybe 100. And mark it every 10 units going up. And now if I push graph, it looks like this. So there's 10, 20, 30, 40, 50, 60 something. So I'm close, because this says in general the max is going to be around there. So to find that, I'm going to go second, calculate the maximum, and it's somewhere between 0 and 5. 0, enter, 5, enter. My guess is 2, and it says no, it's at 1.584 is what I should have folded up. So I should have folded up, my x should have been 1.5854 inches. And my volume, maximum volume, will be 66.148. Ooh, I had more than that. I must have done some arithmetic wrong. No, I didn't. I had 65, and this is 66. So the maximum volume is, if you can see it there, 66.148-ish inches cubed. So I'm paying attention to my units as I'm doing this. A little bit more than what I had. So I was close to giving the right fold height up to get close to the maximum volume. Now, the maximum would have been 1.5854. I used 1 7/16. Let's see what 1 plus 7 divided by 16 is in decimal. 1.4375, and I should have used 1.585. So I was a little bit too small. I should have folded up just a little bit more, and I would have got a little bit more volume. Okay, and there's one more thing that I want to talk about here. If I look at the graph, it has an x-intercept at 0, at some value there, I'm not sure what it is, and another one there. So to find those, If you have Desmos, you can just tap on them and you'll see them. But on the calculator, we got to find the zeros. So I did second, calculate. And one of them is at 0. It looks pretty clearly. But one is between, looks like it's between 4 and 6. So I'm going to say between 4, enter, 6, enter. My guess is 5. And it says, no, 5.5. Oh, there's one out here at 5.5. So one of them is at 5.5. The other one must have been smaller here. So second, calculate 0 between 3, enter, and 5, enter. And I'm going to guess 4, and it says 4.25. So at 0 inches, 4.25 inches, and 5.5 inches. It's telling me the volume is 0, 0, and 0. How is the volume 0? Well, if I fold up a height of 0, I don't fold anything up, I'm going to have a box that has no volume because there's no sides. What about 4.25? Well, remember, this paper was 8.5. Half of 8.5 is 4 1/4. So if I fold up 4 1/4 and 4 1/4, that leaves a width of 0. If the box has 0 width, it's going to have no volume. No width, no volume. What if I fold up 5.5? Well, 5.5 is half of 11. So if I fold up 5.5 and 5.5, I'm going to have no length. So no length, no volume. All I'm trying to do is point out that this creates a cubic equation. It has x-intercepts that have meaning to the real problem. It has a maximum in it that has meaning for this problem. There's some areas in here that we might want to talk about what the meaning is of that, but an equation that's modeling a real situation, you can look at interesting parts of the curve and find out meaningful information about the original problem. That's how Einstein made most of his discoveries. He did mathematics on some things and then looked at the math and said, oh, there's some interesting things in mathematically about this. It might tell me something about what's really going on in the world. And that's how he made a lot of his intuitive understandings of our universe and our world, physical world.